Hello students, welcome to Sort of Search classes. Today we are going to solve IIT JAM Statistics 2014 question paper, and the first problem is the equation 3x square minus 12x plus 11 plus 1/5 of x cube minus 6x square plus 11x minus 6 is equal to 0 has how many roots in the interval 1 comma 2, and we are given 4 options as usual. We have to choose the correct answer. Now we call this fx, so let gx is equal to x cube minus 6x square plus 11x minus 6. Note that g prime x is equal to 3x square minus 12x plus 11. So if we just take this and differentiate it, we just get this. So fx equal to g prime x plus gx by 5. Now what is f of 1 is equal to, before that let us just compute g of 1 is equal to 0, g prime of 1 is equal to 2. From this, g of 2 is equal to 0 and g prime of 2 is equal to minus 1. These are easy calculations, which gives us f of 1 equal to 2 and f of 2 equal to minus 1. Now by intermediate value theorem, there is a polynomial and continuous. There's no problem with continuity. By intermediate value theorem, there exists x1 belongs to 1 comma 2 such that f of x1 equal to 0. Now there exists at least one root in between 1 and 2, but leading coefficient is positive. Therefore limit x going to infinity fx is infinity, and limit x going to minus infinity fx is equal to minus infinity. Choose m greater than 2 such that f of m is greater than 0. Choose small m less than 1 such that f of m is less than 0. This is of course possible because of the above two facts. Fx goes to infinity as x goes to infinity, and fx goes to minus infinity as x goes to minus infinity. Now m comma 2 and another application of intermediate value theorem gives x2 belongs to 2 comma m such that f of x2 is equal to 0, and in m comma 1 and another application of the intermediate value theorem, we get there exists x3 belongs to m comma 1 such that f of x3 equal to 0. Its f is a 3-degree polynomial which can have at most 3 roots. We know one root is less than 1, the other root is greater than 2, and there exists one root between 1 and 2. So there exists exactly one root. Earlier we saw at least one, now we check that it has to be equal to 1. So this will be exactly one root in the interval 1 comma 2. And we move on to our next problem. We are given a matrix M equal to 1 0 0 2 4 0 3 5 6. I just read out the columns. Now firstly, m to the power k equal to 1 to the k, 4 to the k, 6 to the k with something in the other 3 rows above. It's an upper triangular matrix multiplying an upper triangular matrix. makes the diagonal entries just scalar multiplications, so this can never be equal to 0 and hence it is not nilpotent. Now since there is upper triangular, eigenvalues are 1, 4, 6. There are 3 separate eigenspaces and hence the eigenvectors are definitely linearly independent. Each eigenspace is a one-dimensional space. Now, is M an elementary matrix or can it be written as a product of elementary matrices? Now, this is definitely not an elementary matrix because elementary matrices would either have the form 0, 0, 1 with 1 and a 1 here. It will either have only ones and zeros in the diagonal, or it can have at most one non-zero value in the diagonal, or it can also be of the form these, and definitely our matrix M is in none of these forms, so it is not an elementary matrix. So by process of elimination it can be written as a product of elementary matrices, and B is our correct answer. Now we will move on to the next problem. The next problem says, let the mappings T1, T2, T3, T4 from R3 to R3 be defined as T1, T2. I'm just not reading out, these are a bit complicated expressions. The question is, which of these are linear transformations of R3 over R? Now, which of these are linear transformations? Now, first thing to check is T1 is not a linear transformation because we have a quadratic term x squared plus y squared here. If we have x1 plus x2, we will have x1 square. I just write it down. T1 x1 plus x2 comma y comma z is equal to x1 square plus x2 square plus 2x1 x2 plus, in the first column this is what, plus y square of course, but T1 x1 y comma z plus T1 x2 y comma z is equal to x1 square plus x2 square plus y square comma other things, which is not equal. We have the extra 2x plus 2x1 x2 term in the first one, and so this is not a linear transformation. T2 is a linear transformation because in each of the terms we have y plus z plus x plus y. However, we will need to check T2. I'll just do it later. Before that, T4 is definitely a linear transformation because each of the coordinates are just linear maps in one variable t x y z. If we make x1 plus x2, we will get x1 plus x2 2y 3z, which is just x1 2y 3z plus x2 2y 3z, and these is the same for all the three variables. This is definitely a linear transformation. T3 is again not a linear transformation because of this xy term. We have T3 of lambda x comma y comma z is equal to lambda x plus y comma lambda square xy comma lambda x minus z, which is equal to lambda times x plus y lambda xy x minus c. We have this extra lambda term here which creates a problem, and hence this is not a linear transformation. So let us check which of the options we can cross out. T1 and T2, T1 is not a linear transformation, cross it out. T3 and T4, we don't know. No, T3 is not a linear transformation, we cross this out. T2 and T3, again T3 is not a linear transformation, we cross it out. The only option that we have left is T2 and T4. So this is the correct answer, and it is obvious also that T2 is a linear transformation indeed, because T2 of lambda x lambda y lambda z is equal to lambda times this entire thing, and T2 of xyz plus x1 y1 z1 equal to y plus z plus, like, we'll just check this once. T2 of xyz plus x prime y prime z prime is equal to y plus y prime plus z prime, comma z plus x prime plus x prime, comma x prime plus y prime plus x plus y, which is just equal to y plus z, z plus x, x plus y plus y prime plus z prime, x prime plus z prime, and y prime plus x prime, which is just equal to T2 of xyz plus T2 of x prime y prime z prime. And so this is okay. T2 is a linear combination. The one small thing that I would like students to note in this problem is a linear map is not a multilinear map. As I was doing here, I actually meant y1 plus y2, z1 plus z2 here. A linear map from R3 would mean T of x plus x prime, y plus y prime, z plus z prime is equal to T of x y z plus T of x prime y prime z prime, and T of lambda x lambda y lambda z equal to lambda T of x y z. These are the set of conditions that it has to satisfy, which means that it's a linear map. Now we have checked that it has to be T2 and T4, and we are done with this problem. If you have any queries, please post it in the comments. Please press the like button if you like the video, and subscribe to our channel if you want more such videos. Thank you.